All right. OK, so I'm Ron Minnich, and I'm here for the Open Systems Firmware track. And we're actually going to have two speakers. I'm the first speaker, and then second is Devender from Microsoft. And before I go a little further, I really wanted to mention that the really early beginnings of this effort were less than a year ago. And the person who really kicked it off and kind of got us where we are right in this room today was Jean-Marie Verdun of Horizon Computing Solutions. So, if you see Jean-Marie there on the floor, he's right back there. Thank him, because I certainly think we all owe him a lot for the fact that we're even here. OK, so why are we doing open systems firmware? And again, the goal here is to mostly have an open source firmware stack for OCP nodes. And the reason is simple. If you look at OCP and what it's achieved in a really short time, it's opened up the data center hardware and software designs, which is pretty incredible. A lot of people I know in 2010 thought this would never go, and it's gone really well. But firmware is still, if you think about coming down from above with whatever software you have, it's your thing, and you come up from the bottom with the hardware designs. There's this giant hole in the middle called firmware. And the rule, at least where I've been in this thing for a while, and the basic rule is if you don't own firmware, firmware owns you. And get ready to be owned, because it can happen. It's an operating system. It's always there. And it can do things you don't know about. But the really neat thing is if you do own firmware, you can actually do things that look like a hardware customization, even though you're just changing firmware. So at Los Alamos, back 18 years ago when I kind of got into this whole game, we would put Linux in firmware, and we would build nodes that only knew how to be supercomputer nodes. They couldn't boot from a USB stick. They couldn't boot from a floppy. There was never anything they knew how to do but boot from the network and become a supercomputer node. No hardware changes needed. We just changed the firmware. So there's a lot of good things you can do in there once you own firmware, and there's a lot of danger for you if you don't own firmware. It's two sides of that coin. So we want to support as many OCP platforms as we can. If you go to the Facebook booth, you're going to see a switch and an OCP node both running Linux boot today. We hope this can accelerate innovation in the cloud. And one concern, especially from 2 Sigma, is getting an ability to establish an owner-controlled root of trust. That means the owner owns the root of trust, not the guy that made the board or the company that made the board or whatever. Especially given that owners change over time. That's extremely important for decommissioning of nodes, that sort of thing. So this is going to be an open source stack for OCP nodes. We're going to do that to the maximum extent possible. One of the things we've kind of accepted going in that we really didn't want to accept from earlier years is there will be blobs. And in particular, those blobs will be things that turn on DRAM and train it, or chipset things that for whatever reason can't be released by the vendor. But for anything that's not a blob, we want, say, if we have release source, it's got to be possible to build, burn, and boot that source. Now, there were some phone vendors back about 10 years ago that released the Linux kernel for their phone, and it came with this little asterisk at the note that said, oh, by the way, this won't even build. And by the way, even if you could get it to build, you're not allowed to burn it because you can't burn the firmware in the phone. And by the way, even if you were able to get it to burn the firmware in the phone, it wouldn't produce a working phone because it wouldn't boot. So the rule here is if it's open source, you can build and burn and boot it. And further, we're looking at replacing some components with modern languages like Go and Rust and Spark. And one pioneer in this is Coreboot. There's a VGA setup bit of code in Coreboot that's written in Spark, which is an Ada variant that allows for formal proof of the code you're writing. So there is some precedent here for going with non-C in the firmware. We want to have continuous integration and validation. We've seen some cases with EDK2 where we turn on an option and it doesn't even build anymore. So we want to make sure that whatever we have always builds. And finally, we want to provide mechanisms but let owners create policies. And what's that really mean? So mechanisms are a way to do things, like turn on your node or whatever. And policies are what mechanisms you use and the order in which you use them. So for everything from data center and laptop, we've come up with 3 profiles: high touch, low touch, and no touch. So high touch is your laptop, say. No touch is a node in a data center and who knows where, or somewhere north of the Arctic Circle. Your policies on what you do with high touch and low touch systems are probably going to be different. Classes of policies include security, failure, recover, manufacturing, and decom. So what you do when you're building it might be very different from what you do when you decommission a node. So that's the whole life cycle. And one of the key policies is what happens when things go wrong. So for the data center, our policy has got to be boots, not bricks. So no matter what happens, even if you come up and something says, I don't even trust the firmware that's in you, Then you go into purgatory and you contact this host that is there to manage what happens because you're messed up. And that's a boots not brick scenario. Now, in a lot of cases on, say, laptops and things, the UEFI policy has in the past been bricks not boots, and that's not something people like, but there are cases where you do want that. And we're going to need mechanisms for debricking. Now, main purpose of this slide, if you can think of a policy that we need to think about, come and talk to us, right? We don't pretend we've covered everything here. We want to make sure we don't rule something out that you need. All right, so now I'm going to switch to Linux boot. And the structure here is I'm going to talk about Linux boot, and then Devender is going to describe OpenEDK2, which is a new initiative from Microsoft. I need to make sure, I'm not trying to imply that I did the work here. There's Facebook and Horizon Computing and 2 Sigma and 9 Elements. We've had a lot of people involved in this work. So the big picture, we want to use Linux and an initramfs as the flash-based bootstrap code. That's all this is. There is a Linux Foundation effort called Linux Boot that builds on this. So Linux Boot just came into existence last December. This work extends cross-architecture. So we want to cover, for example, and this has actually already been done, x86, Open Power, ARM, and RISC-V. And we want to work across any firmware. So again, this has also been done. Examples, UEFI Core Boot and U-Boot and Host Boot. So we want this to work in all those environments. And we want Linux to start in the process as early as possible, which boils down to once RAM is working. Here are some examples. Linux on Core Boot. We are able to get rid of a lot of Core Boot if we want. Linux on UEFI, we can remove lots of UEFI. We've tested this on Power 9 Opal, and we've also tested this on U-Boot. So here's kind of a picture. And a key thing here is this is turn on RAM, right? This is UEFI PEI, which boils down to get RAM working. Here's the Core Boot ROM stage, get RAM working. And then, of course, the U-Boot SPL, get RAM working. Fine, RAM is working, and we're done with you people, right? We're going to move on to Linux. We're done with the firmware part. And so we get to where DRAM is working, we load Linux from Flash, and we start it. And Linux does a lot of things that it didn't used to know how to do, right? Back in 2000, when we kind of started trying to figure out why Linux couldn't configure PCI, the answer was because Linux can't configure PCI. So we had to write extra code in Core Boot to cover that case. But Linux is great at configuring PCI now, and a lot of the times the firmware does it wrong anyway, at least wrong for Linux. So Linux will do the PCI and the buses. It does a lot of work that UEFI, Dixie, or Core Boot RAM stage or U-Boot platform code used to do. We do that instead. And then we start the initramfs. And we've got 2 demos in the Facebook booth where we basically run /init. Then we can do things like locate a kernel and start the kernel and then netboot, that kind of thing. So that's the model of Linux boot, basically. You can have a lot of variations on this, right? I mentioned an initramfs in Flash. There have been cases I've seen in past years where people just said, no, I don't want an initramfs. I'm just going to mount a drive that's attached and use it. You can do that, right? So I don't want to imply that the initramfs has to be there. I don't want to imply anything. I just am saying that there's a Linux in your Flash. Now, this is kind of a UEFI world here in open compute platforms, so I'm really just going to mainly focus right now on UEFI. If you look at the UEFI stages of booting, there's the SEC, the PEI, and the DXE IPL. We're not going to touch those. It's really kind of tough to even think about touching them. Those are blobs. Even on ARM, they're blobs, and so we're not going to go there. We're going to join the party right here. And there are 3 ways we can join the party. And basically, I've kind of got green as being the easiest and orange as being the hardest. They get a little tricky. Green is the one we always do. We take the DXE shell and we replace it with the Linux kernel. And that almost always works the first time we do it, because the DXE shell is only started by UEFI after pretty much everything is done and you're ready to run a bootloader. So the odds that this is not going to work are very small, and in general, it works. The next step for everyone who's ever seen a BIOS menu, that BIOS boot screen, what hard drive do you want to use, whatever, that's called the BDS for boot device selection DXE. And we are now replacing that on some select nodes. It doesn't always go smoothly. There are a few tricks because the guys who write this do some odd things at times. But in the Facebook booth, I think the node on the left, the Winterfell node, we're running with replacing BDS Dixie with Linux. And then finally, this is the thing Trammell's been pushing really hard on. Dixie Core, that's pretty tricky because this thing actually runs other DXEs. And if you replace this with Linux, then Linux has to run those DXEs. And that doesn't always work. It's something we want to work. I think it's the long-term plan is to be here. I think for the next year, typically we'll be here. and this is again just for testing, but we've had a couple of people say they would stop there for what they're doing because it's so much better than what they've got. They're fine with it. So, again, there's a lot of variations on how you do this. So I'm just going to show two initramfs examples. These are not the only things you can use, but they're two things that are in use. If we take Linux boot and a project called uroot, we form a thing called nerf. This nerf has a lot of Go versions of many of the standard Linux tools, and you can do this in a way that those programs are compiled dynamically. So you type date, and it compiles date and runs date. Or you can do it in a way that's more like BusyBox, where there's one binary, multi-entry binary that is built from all those Go tools. And you type date, then it's a symlink to a single binary and looks at argv of 0 and does a date function. This one's kind of fun. The security guys that I talk to like it because all the source is there. This is kind of neat for actually a real root file system. It's about 5.9 meg in the initramfs. This is called BB mode. It's kind of a nod to BusyBox for the good thing they did. And this builds in 20 seconds and results in about a 3 meg initramfs. And I've been told actually you can get a little smaller than that, but we just haven't done that. I haven't personally done that yet. OK heads is from 2 Sigma. And again, the expert on that is Trammell, who's sitting there. And I can embarrass. You can raise your hand for people who want to. Yeah, OK. So heads is a configuration for laptops and servers. And the goal here is to make free software all along the boot path, move the root of trust into hardware. And really, so you've got this laptop, and you boot heads. And you can make a statement about sort of, you can tell me I said it wrong later, but essentially you can measure everything all the way up so that when you finally get into cubes, which is what it starts, you have a real strong reason to believe that nothing got in the middle and did something nasty to you. So it can measure and attest to the state of the firmware, and it can measure and verify all the file systems, which is pretty cool. All right, so when things go south, it's time to recover, and this is where having Linux and Flash can be really nice. You can put an SSH daemon and network drivers in the initramfs. Oh, you've got a node didn't boot? OK, SSH to it. Talk to it, see what's wrong. It's running Linux and an SSHD. It has a shell. It has a bunch of Linux tools. You're good to go. Technically, and again, this is something we kind of did at Los Alamos, you don't even need serial console anymore. You've got SSHD. If the network's not working, what do you care? It's a data center. It's kind of a useless node anyway. So you can actually then have things set up so that in the worst case, when everything is just going south and boot's not not working, you SSH to the node. And we can use things like the core boot mem console driver to look at the logs. And we can also have the OpenBMC, which is an awesome project for doing things like out-of-band recovery. So here's the big takeaway. The entire universe of Linux tools is part of your recovery. And to put it another way, and I don't know if the Linux guys will like this, but they're now all firmware programmers too. Yeah, sorry, you're now firmware programmers. So here's some early results for UEFI. The boot time on the OCP Winterfell, we got down from 8 minutes to 20 seconds. We reduced the attack surface in some sense, 122 modules on the Winterfell down to 29, or 400 modules on this S2600 platform down to about 90. We'd like to reduce that further. We've got about a dozen platforms tested, and we're working on the AMD now. And I actually spent some time this morning talking to somebody at ARM, or not at ARM, an ARM company about UEFI and the 64-bit ARM. And Horizon Computing is deploying it. So that's a rack running a continuous integration framework. And we actually have a Pixie boot program written in Go. It behaves just like Pixie boot, but instead of running in 16-bit mode out of Flash, it's a user-level Go program that does the same thing. And they're able to use that too. And basically, they're going to be shipping this Linux boot nerf cluster, end of this month or beginning of next month? Something like that. Beginning of next month. So that's really cool because we actually really only started this project in January 2017. We really only made it public literally a year ago. We decided we needed to bring people in, and so we made all this work public, and this has moved really quickly. So code, we have a couple of repositories. If you go to github.com, Linux boot, you can look and you can see the 6 boards we have supported really completely directly. From git clone to a build image is 3 minutes. And then we've got OS research heads and uroot. These are all at github.com. And then we have this new thing called Fiano. which I've talked to Intel about and are pretty cool with. They like it. Fiano is based on Tiano Core. It's sort of a downstream copy, but only the things we really care about. By the way, that's Fiano. It's empty. I don't know how it got empty, but it's empty. So, but it's going to be, I'm lying a little. We don't actually have it populated yet because people had to get permission from their companies to contribute, but it's this or is it? Is it populated? No. It's going to be a repo of tools that we've created. We will sync from ED2 to, I talked to Vincent Zimmer. He's totally cool with if we build nice things, we'll push it back up. This was kind of the Linaro process. And this is going to be small. So EDK2 is big because it's very comprehensive. This is small because most of what we want is already in Linux. And so we're going to have the tools. We're going to write a lot of those tools in Go. We will follow contemporary coding standards from Linux, because if you're going to bring in Linux people, you'd better follow their coding standards or they'll ignore you. So, we're going to be moving to these contemporary Linux standards. We will not have UEFI applications because we're moving them to Linux user programs. And we're going to limit what the Dixies do and move that into Linux. And we're going to do a little cleanup. So this is a piece of code that came from Red Hat. Sorry, Red Hat. So this is a function called microsecond delay. And if you are lucky enough to build this into an EFI image, then you're really lucky and someone calls it, you'll hit that. And then you've got a brick. So this is the bricks not boots policy. And it's really not something we want to have. So we're going to look for things like this and make them go away. So Linux boot is a pretty radical departure, I think, for OCP on one sense. On the other hand, what's old is new. This is kind of how we built supercomputers at Los Alamos for about 8 years, until IBM came in and refused to play. So in some ways, I think we were maybe too early, and the community wasn't quite ready. But we're finding really great support from Intel. Vincent Zimmer especially has been just terrific. We're finding partners, Two Sigma and Horizon and Facebook and others who feel that this is a good way for them to go. So I feel like this time around, the stars are kind of aligned to make this happen. Here's the contributors. I won't list them all, obviously, but it's Horizon and Facebook and Two Sigma and others. Andrei Marchovsky had a lot to do with the early Go code, that's the Cisco involvement. Linuxboot.org, and there's a conference coming up this fall, September 13 to 16. Be wonderful you were there. That used to be the Core Boot conference. Now it's the Core Boot, Tiano, Linux Boot, whatever conference. We want to bring people in who are doing open source firmware. And people from this community are particularly welcome. Could even be OpenBMC stuff. And we do have a Slack channel and a mailing list. So you can start sort of at the root of Linux Boot and find these resources, or you can mail me, rminnick@gmail.com, or find me after the talk. And that is it. So the next step, Devender is going to describe a new start that he's got going about OpenEDK2, and then we'll talk about the work streams at the end.
Can we ask them questions?
We can. I'm really worried about cutting into Devender's time, but we have 2 minutes. 2 minutes, yeah.
So how debugging is in this particular mode? Debugging any issues?
OK, so that's kind of the fun part. Anything that you use to debug Linux, you can use to debug Linux boot. So I can tell Linux people, all that stuff you have to debug a Linux when it goes sour on you, you've got that same set of tools to debug Linux boot. This is where the big win is. So anything that community relies on, they can rely on for firmware. That's why they're all firmware programmers. Like it or not.
Oh, yeah. You can, yes.
I'll just turn
switch
this
off that, yeah.
This is going to work. Switching monitors is going to work.
Yeah, the trick. Still thinking. Yep. Anyway, it's the final stages of the summit, but probably everybody, one of you guys are almost tired. So my name is Gundrala Devender Goud. I go by Devender. I'm a firmware manager at Microsoft. And so I spent quite a bit of time at Intel doing the high-end servers, including the 8-socket, 4-socket, and whatnot. So I want to focus on how we are trying to come together as a community to collaborate and do something revolutionary in the coming future, right? So this was in a short notice, probably 6 weeks. 6 weeks ago, we just said, okay, this is a great idea. Why don't you start coming together and talk about how we can open source the system firmware? And within a short period of time, we reached the consensus and we tried to come together how we can do that as a community. So let me go into some details. I know there's a mixed audience here. Probably I just want to take a minute and make sure that you guys know what I'm talking about. So there are different firmwares at a rack level. Our unit of hardware piece is a rack, right? It comprises of all kinds of nodes. And then inside each node, we have different types of firmwares. And you can see there's primarily two planes, a control plane where there are no customer workloads are running. This is mainly meant for managing the whole rack. And they have also firmware. And there's a data plane where we talk about the different types of firmware. And what I'm focusing today is on the red box. And you can see there are multiple components in it. And in our world, at least at Microsoft, in data center world, many people, they use the UEFI. So I'm just using as a generic term. But we'll switch over into the next topics. So is everybody clear what I'm talking about? Hopefully. All right, so my experience tells me, Ron experience he shared, and there is a complementary aspects to it in the business part of the story where how we develop the firmware today in terms of the system firmware and what are the challenges we have today and how can we really solve them coming together. Is that what I'm trying to paint a picture here? So if you see from the top is closed, the whole firmware is really proprietary and it's closed right now. Pretty much, obviously Linux boot is open for a long time. But in general, the commercial products, they're closed and it could impede the innovation, or if you're trying to do some kind of a new rational, like in terms of the POCs, or you're deriving products out of the baseline designs. As an example, Microsoft Mount Olympus, pretty much every week we come up with a new SKU by changing certain basic things inside the hardware. So what it drives is, okay, where's the firmware, right? So the hardware is innovating at an accelerated pace, but people are looking for firmware delivery. And that is a key challenge, being closed. If you try to open it up, then probably we can solve that problem. And the second one is an interesting one. The variance in boot flows, if you take the top 3-tier silicon vendors, Intel, AMD, or the ARM variations, you see the initial boot flows are totally different. And when you try to come up with a system firmware which is commercially viable, we need to think about that. And as soon as you have variances in the boot flows, when you're doing a product level, which is a commercial product, then we are talking about, okay, you're morphing your own firmware to different environments. And all of a sudden, without your realization, you'll have 25 firmware sitting around in your source code. And then you have to manage them. That's very tough problems. So one of the efforts we are trying to do is, okay, how can we come together, at least an architecture-based, we can have a single answer to the question. Obviously, we can customize it for our needs, right? So that's one of the other challenges we are trying to solve by going open. And then the other thing is in terms of the CSP models, the cloud providers, everybody has a different type of business strategy or the workloads or the work models. And what happens is you don't have a single firmware, even if it is supplied by some IBVs. We don't have a single answer to the question of all the CSP workload models. But going to an open community, there's an opportunity, tremendous opportunity to come together and then solve the tough problems. Why reinvent the wheel, right? So that's the thinking there. And then system firmware development models are not able to keep up with the hardware innovation, which is going on at almost they are on the high octane bandwidth, like they are just rapidly growing. What I meant is there are like probably 1,000 companies doing different hardware designs and component designs and whatnot, and everybody needs a firmware and some level of customization. In fact, in our division, we just have a new hardware design, and every week they spin another flavor of it, and where is my firmware? Give me a break. I mean, we need to think about, okay, how do we scale the resources to that kind of an environment, right? We have only a couple of IBVs which are serving the market today. So these are some of the motivations, and then the last but not least is the cloud readiness, right? How can we make a firmware which is cloud ready? I'll talk more about what I meant by cloud ready. Today, we are just patching through and then taking even the enterprise class server is not serving the cloud use models. So I'll talk about, these are some fundamental reasons, challenges on top of what Ron articulated in the beginning. We need to go open. Here is the chance, and here is the transition in terms of the industry transition, right? So truly, yesterday Badruddin and Kushagra, a lot of people from Microsoft were talking about, we are truly not open. Even Bill Carter was mentioning that. Unless we go truly open firmware, open hardware is useless without an open firmware. So that becomes a truly open solution, right? So these are some key motivations. At least we discussed in our forums, and we wanted to solve these tough problems by coming together. That's the key goal. So how did we come together? We debated, we discussed, and different models, and how are we going to even address the entire landscape, like the challenges I articulated. And Ron and I and the entire team, a lot of people, probably 15, 20 people from 20 companies, they worked through the 4 or 5 weeks and try to come together. This is nowhere near to the architecture block diagram. This is just meant to digest the problem, partition it so that it is in independent blocks. We can go drive the openness. So if you see here, Ron has mentioned a lot of goodness in Linux boot as well. So you can see the path which we can go through the Linux boot is somewhere, so maybe I can go here. So you can see the Linux boot path, the PEI can be leveraged, and then you can go this way to boot to the, even in fact, at some point, hopefully they'll boot to the Windows side also. And then the other aspect which we could go, other path is we can go this way. So, but what is the commonality? Like he mentioned many times, the Vincent Zimmer name. Yes, Vincent is the industry leader in terms of the firmware development in UEFI world. This module plays a key important role so that you can interplay between this way or that way or any different ways, right? But the contribution, this is all, in my opinion, it's all the strength-based model. So we are leveraging the strength of all the Linux developers. We have invested into almost 20 years into this particular channel, so we can leverage that. And you can see the different silicon vendors. They can interplay with any operating system boot using a common layer. So that's the goal here. Again, these are all, like, the problem is very tough and it's difficult to come together as a community and invest in the right things. So this is a picture just trying to pass through so that we can identify some blocks and align with the strengths of different companies. So, and then the next one, we will talk more about this one probably at the end. Ron, is that okay? Yeah. Let me switch gears, and I wanted to talk about, okay, what are we doing in the OpenEDK 2 work stream? Ron has some good points in terms of the Linux boot, but OpenEDK also has some value proposition, and I'm happy to say the Microsoft almost 2 million servers are running, data center servers are running on OpenEDK, and in the world probably billions of devices are running already in EDK based. So the history is important here because this history is where it cemented us in terms of the strategy where we are going in terms of the Microsoft overall plan. You can see I've been there at Intel during the 2000s, and when they tried to transition from the legacy BIOS to the UEFI BIOS, and first sample implementation was put out. I can see Harry here sitting. So long time ago, and it was an experiment, and the frustration was, okay, the assembly coders are very sparse, and then you have to go hunt for them, and then the products are getting proliferated. How do we really address that problem? At that time, the motivation was, let's write the BIOS in C code. And then there hit the problem, okay, where is the stack? And then Intel solved the problem with the NEM modes and all that. So there, the project started slowly, but it grew like dramatically. And initially, they tried to open it up, but I don't even call that is truly an open source, right? So the key pieces are still not open. And then they formed the Tiano core, and after that you have the UEFI org. And today, 2017, I pulled some data. Around 240 companies, the MNCs, the big dogs, are playing into the UEFI. And then I would say estimate in terms of the billions of devices are running in UEFI core code, right? But the industry has successfully transitioned, and there's a lot of maturity, stability, and then the tech equity, I call. So you have invested so much, 20 years of equity from different companies. I would say world has probably maybe 1,000 BIOS engineers, maybe 10,000 BIOS engineers. I don't have a number, but people have worked hard to transition to this point. But my key point here, what I'm trying to make is yet another transition. Now, whatever UEFI is in that shape is not good enough. And for the reasons which I articulated in the very beginning, there's a lot of challenges we need to solve as the cloud is really growing faster, right? So let's leverage what we have invested in it. And this is a block diagram, pretty familiar and very high level, and everybody knows, and even Ron talked about the sec phase, PEI, and Dixie. So this is a pretty normal stack, and what we do in a product BIOS, right? So if you see here, this portion is probably it's a silicon vendor's aisles. Even though we have some kind of platform interfaces to it, in terms of the Cerberus or whatnot, all those interfaces in this modules. But when it comes to the Dixie execution phase, there are challenges. As I was telling earlier on, this is not cloud ready yet, because whatever we are using, you can see tons of files which we never even exercised during the cloud boot. And then there is the optimizations required here. The key piece is the runtime piece. So in the cloud, where you have an availability goals of 5 nines, which translates into you can afford to go only 5 minutes in a whole year in order to serve the customer SLAs. That is a big deal for, at least for Microsoft, the business model we are in. So the runtime portion, it's not only detects the error, but there should be some technology to even to heal, the self-heal kind of technologies. So there are some problems to be solved yet. So in terms of the current gaps at a very high level, it's not truly open. You can peel the onion, and then you can see a lot of proprietary code still shipping in a lot of cloud vendors and enterprise devices and whatnot. And then obviously the chipset modules are not open. And then it's not optimized for cloud models. So what are we doing about it? So we expect to solve all these challenges through our work stream, OpenEDK work stream. So here is a picture back again. What we wanted to play contributions into the OSF is this path, and in that path, what are the things we should be solving? We have some goals to solve in the OpenEDK. Again, this is a 6-week project. I don't have much exciting things to show, but I do have something at least to share. So make complete tree open. Today we have just UEFI core and the silicon modules, nothing is open yet. And support the multi-silicon architecture. You take Intel, they care about sec phase and PI, and this is completely different in terms of how it boots the operating system. I mean the basic root of trust and all. This is totally closed box, and then we wanted to at least make an attempt to open it up with a silicon interface firmware interface modules. And ARM vendors, this is ARM is always little different because there are multiple players in it. And obviously, if you have a standardization, then all can even leverage that too. And then the power host boot, Ron talks a lot about it. This is also important for probably in the future. And then the core boot, which I saw a cool demo from Facebook friends, so that was cool. And our goal is to, okay, multi-silicon architecture and multi-OS. And when we say multi-OS, we obviously talk about Windows as a Microsoft, and we do have some workloads which run on Linux too. So we wanted to target that too. And then standardize the root of trust interfaces in the sec. So this is the key module. Brian talked last hour. There's a lot of good questions. We wanted to stitch all the interfaces like bias measurements and all that root of trust to some of this architecture and blend into it. And this is the key one where Intel stepped up, and in fact, Vincent Zimmer is going to drive this architecture interfaces so that it is pretty agnostic to what is going on below, and then the above layers can call into these interfaces as a standard mechanism. So that way, we are talking, probably you can say a German guy talking to somebody else in a different language, but with an interpreter in it. So it's kind of that analogy. And then our use models, this is a key for us. We manage all the servers in the data centers remotely, and we make their fleet, we call fleet, and they're even the software, hardware, all this hygiene to up to date. And this becomes a very important aspect for us to out of band manage it. And we sometimes, in worst case situations, we go through BMC and recover sometime. So this is what I was talking about earlier slide. The current solution of the cloud is not cloud ready. I mean, in terms of the UEFI, we just cobbled together everything and then it boots and it works. That's good enough for now. But we need to think about, we did address this part of the story in the context of UEFI. What I meant performance is how much time faster you can boot from the reset vector to all the way to operating system. And we have optimized this to death. I mean, we were somewhere, like Ron was mentioning, 8 minutes in that same range. And we are cutting down to a 6 terabyte machine with a 2-socket and a big dog machine. We are now able to do it in 28 seconds. So which is pretty amazing. We have optimized that code really fast now. Reliability is another aspect. Yeah, you can deploy the server, but if you take the rest of your life to keep on maintaining that, it's of no use. I think reliable, once you deploy, you don't want to look back at all. Let the customer run on forever, right? Ideally, but that's not the case. Once in a while, you have to maintain it. So that all translates into some of the interfaces, runtime interfaces into the UEFI, and we wanted to invest in that area to make it much more robust. And serviceability. So Brian also alluded, we have this updates once in a while to maintain the fleet hygiene and then service the customer without impacting the customer. There are some SLAs where you can be predetermined at such and such date we are doing maintenance, and then we go make all the updates and make it the fleet hygiene up to date. I mean, look at some of the security updates, we have to do it in a hurry, right? So these kind of provisioning, the serviceability aspects are pretty key for the cloud workloads. Yeah, it may not be much for consumer devices, but for cloud, this is very, very important. And scalability. So you want to address a problem at a scale. So sometimes the problems are on multiple servers in different locations and all, because it's some kind of a bad hardware got shipped into it. A bad set of hardware shipped from vendor, and then they upgraded it and something went wrong. And then how do we scale at that? So you don't want to go to each machine and then try to update the firmware in the real time, right? So you wanted to deploy a package, a personality module or something to update at once. So the scalability is very important. And then when you build new machines in the manufacturing pipeline and then you wanted to deploy and put all your top layer software stack into it, that is I have seen there's a lot of people working on that deployment. When I joined Microsoft, I was amazed, like, okay, is this even a division to deploy a firmware into the existing hardware? But I can tell now that is a big deal, because when you are trying to increase the footprint of your data centers, and the time to market is so important, very critical. Customers are waiting for the machines to get deployed. And the deployment strategies blends into these structures, into the interfaces, where they make the personality of the UEFI different for different SKUs. So the deployability is also important. All these things exist today, the capabilities exist, but they are not optimized for cloud. They are just optimized for the use models which are meant for an enterprise servers. One can manually go and do things, but at scale you cannot do those things. So our goal in this work stream is go refactor some of the code modules to make address these kind of things. And I'm happy to report, and thanks to Malik. Malik is one of our firmware managers. He works along with me, both of us together. And he made it happen with the help of Intel, Harry and Vincent, all these people. So we have uploaded the first initial EDK to open, totally open. You can go download it and build for Mount Olympus. So if you buy a Mount Olympus, you can boot now on an open EDK, open source basically. And so the key message is, let's accelerate this, and then whoever is interested, come and join and then contribute. So I want to go back to, and Ron, why don't you come over here? So we discussed like the picture which we initially said, how do we really come together and then make it happen as an total open source, right? This is a shared responsibility. We are trying to solve a shared goals, shared problems across the industry. So there are a lot of people came forward. I see Trammell and so many people trying to contribute to this. And then I highlighted two big streams which companies signed up for. And if you see the Open EDK, Dixie Core, which I talked about, is Microsoft and Intel working together. And then the Linux boot, Ron will talk about. So you want to touch on some of the modules here?
Okay. Also, I forgot. We did bring swag. These are Linux boot stickers. And I'm going to quick say we have the old Linux boot stickers, which got improved, but we need to give these away. So, they're here. So should I talk to the Linux boot and some of the others?
Yeah, some relevant.
So right now, there's two main active streams, of course, and,
Yeah.
and the Linux boot is kind of the one that I spend most of my time on, which is Google, Facebook, Two Sigma, and Horizon. We need people to look at, and the headline here is, here's where you go to talk about more of what's going on. We don't have a good automated test support picture at all. And we could use people with expertise in that area. And the idea is, and I know this is done on things like Chromebooks, but we kind of need it on something like this. You push a commit, and we would really actually like, before we even bring that commit into the repo, to know that it booted on something. So that means you push a commit, that gets pulled down, a full stack gets built, it gets burned into a machine, the machine is booted, we have something monitoring the serial port, and we verify that from boot to boot, we get the same output. So that would be very, very nice to have. Nobody ever likes build tools. That whatever we have today, they want better build tools. So Two Sigma is kind of heading the build tools thing. Bootloader support's kind of weird because really with Linux boot, there is no bootloader. Linux boot is doing the booting. But again, for OpenEDK, we need to talk about things like that. And then a really huge one, and again, this discussion is ongoing with Intel and others. Right now, to get the firmware variables in x86, you have to do a pass-through system management mode. And that's a huge exposure because that's a 16-bit vector. So you yank an interrupt to look at a variable, and all of a sudden you're running like a 1978 8086. I'm not even making this up, right? And so there's this period of time where you're running like an 8086, and all bets are off. Anything could happen, and then it goes up to some other piece of code which you don't even have visibility into. It's hidden from you, right? What did it do? Did it get exploited? No way to know. So we really want to figure out a way to do firmware variables that doesn't involve SMM. And I had a really funny talk with the ARM person I was talking to this morning, and he said, yeah, somebody mentioned SNM and for ARM, and he said his head exploded. So, right, nobody wants that stuff to propagate. So we want to find a way around that. And if I'm missing something or something you should add, let me know. But
I think it's not visible. I added one more. The security coding standards is one important aspect. As soon as you go open, then everything, the doors are all open. So we need to at least inculcate some kind of a discipline in terms of how do we develop the modules for this open initiative. So I added this. I think I saw some of the passionate people. Probably they will attend some of our meetings and take on that.
Yeah.
That's one. And then the telemetry and diags is another area. We were debating last meeting whether we should make it as a part of every module, like every module will supply a telemetry and diags path, or the module itself on its own. So there are different theories there. And we are trying to invest. So I think the ground is up and running right now. These guys have done a good job. I looked at that demo, it was pretty cool. And we have already uploaded the EDK. Now, how do we really stitch all this together to make it really open and really solving the industry problem, not one's own problem, right? And at scale and at cloud ready, all these other aspects are important. So I think that's pretty much covers here, but
I think the big takeaway is we need all the help we can get.
Yeah, so this is where Ron, I think the call for actions, there are a couple I jotted down few last night, and there is a weekly call, the OSF OCP weekly call, and you can go to the OCP website and then get the details for dialing into it. And encourage each one of you are industry experts, and you put all this room people into one, maybe 1,000 years of total experience, I can see. So everybody has a unique thing to bring to the table. So please come, articulate your challenge and your ideas, and if you come up with a good idea, you implement it. So that's good, right? So, and then this is a great opportunity to showcase at an industry level. At least my experience has been joining this committee was really helpful because even though we do a lot of things, our things are restricted to only the company we work for. But if you come to this kind of open communities, you will be recognized as an industry leader based on your contributions. So it's a great opportunity for young people. And identify additional work streams. So you can send emails to Ron and myself, or you can dial in and then bring the new work streams. So we didn't solve the complete puzzle yet. We are not claiming anything yet. So this is an initiative where we are coming together. The first stepping stone is looking solid, and I think we need to build upon that. And thanks to Ron and a bunch of other folks, Trammell and Gary and all these people. So that's all I have, and we can take both of us some questions if you have. And yes.
So one big difference I saw between the two proposals is the runtime firmware philosophy. So Ron, in your presentation, you had completely disabled IntelliMe and SMM, but
Oh, yeah.
So whereas
Yeah.
the open UEFI still seems to
Yeah, I think the
things like UEFI runtime. I think UEFI runtime services you omitted in your proposal as well, correct?
I think our plan is not to have them.
yeah.
And
So
reality always intrudes, right? But that's the current plan.
yeah. So we have some history and legacy, and certain things are running today. And when we transition into new world, yes, you are right. I think the lesser the SMM intrusion, especially for different architecture, the better off we are. But we need to address the other aspect. How do we really take care of the runtime error logging, or runtime reliability, or runtime handling, right? So that problem is yet to be solved. I know Malik have published some papers and is working, and he is big time into it. So we know what you're talking about, the problem, but it's not going to happen instantly, right? So we have certain things in the pipeline, but we do want to address that runtime. How can we even eliminate the SMM? Because some of the architectures, like you're from, I kind of remember your voice. So certain architecture don't support that heavy infrastructure in terms of runtime, and certain they depend on them, right? So we need to solve that problem. Yes.
Yeah, and I guess that's what I'm asking is for things like get real-time clock. How do you guys get real-time clock without that API, or what are you planning on replacing some of these APIs with the runtime
Some of the
services?
UEFI runtime services.
So people leverage for the tool set.
Do we use that? I have to go back and look. I didn't even know we used it.
Right, but sometimes there's timer synchronization events that you don't have to call it. What you get at root may not always be what you would want. You may have to call it at later phases.
Wow.
Well, the device is directly now.
Yeah.
Okay.
Yeah, I don't think it's an issue.
Device driver port is underneath the runtime services.
Okay.
Yeah.
I mean, so you guys directly map the DMC, RTC, and is that typically what you guys do?
Yeah, I mean, as far as I know, it's never been an issue. But at that level, most of my knowledge comes from Chromebooks, and I know we don't even have UEFI runtime services. So, I know it's doable, but I shouldn't really claim I know what Google servers do here because I haven't looked at that part actually. So, there was a question here, right? Or
I was a little worried about silicon vendor confidentiality on unreleased platforms, and coupling that with a open repository. I know your companies have the same NDA access as mine, but that's not universally true. Is there something from the Linux side that could point or are you expecting that the silicon development companies will relax their NDAs
I see what you're
early
saying.
enough in the cycle to allow next generation code to be in a public repo.
Can I say, or
Yeah, go ahead.
we really, that was that one diagram I showed. We really want to make clear this does not require anyone to open source the silicon enablement bits, right? So there's the first instruction after power and reset, and the key, at least from our point of view, UEFI defines this PEI to DXE handoff. And that's the boundary. Below that is where all the secret stuff lives, which we don't require be open sourced. And above that boundary is,
There's lots of secrets in Dixie.
No, I think you are asking during the development or during the production?
I think during the development is
Yeah.
the question. So if you want to do
Oh.
UEFI in the open, how do you incorporate new technologies in time? You know, and how do you allow other people in the industry participate in new technologies?
Yeah, so yeah, I got it. I think it boils down to the maintenance part of the story, right? So if there is a new chipset Intel is coming up or AMD ARM, they are always
Sure.
coming up. So that the tree is, it will have a support for that. It's like an industry spec, like for example, you have UEFI 2.6 or ACPI 5.0 or 6.0. In the transition, the specs are out already for review, and then people can play with it. So what the commitment, at least for one vendor we got today, is they are willing to put it on the GitHub as an FSP module with clear interfaces.
yeah. I mean, it's a tricky thing, but a secret's a secret, and we're not going to tell people they have to open source a proprietary thing in order to play. That's a non-starter.
FSP is just one tiny part of the secrets.
Oh yeah, yeah. Well, let me give you an example though.
New fabrics, new kinds of memory,
Sure.
new network controllers, new.
Right,
These are
but-
all Dixie Fingers items.
Yes, but just as one example, I can think of a NIC that has a Dixie, but it has a Linux driver. And the Dixie is doing something I no longer care about, which is Pixie boot. So I can throw that Dixie away. And again, in the case of the 400 Dixies on that one board, we've already determined we don't need 321 of them, and they're all proprietary. So it's honestly a case-by-case basis. You either decide you don't need the Dixie because it's doing something Linux does better anyway, or you don't need what the Dixie does, or you're going to have to keep the Dixie in there because it's got to stay in there.
So my experience has been generally there is always an incremental development in any company. So there's always there's something exists today which is matured and all they add on top of it, right? So if Intel coming up with, another 68 core part, yes, the cores are changing, doubling, whatnot. There are other technologies. It will be the bare minimal boot flow, the FSP module from Intel versus some M.2 vendor is coming up with a newer capacity M.2. A NIC vendor is coming up with a new option ROM or new driver. So those are all some incremental things, the bare minimal to boot or to use for development. I'm assuming, and we are going to talk, that's where the whole thing coming together.
It has to be some.
Yeah, it's a good question though. I think what do we do during development versus the post development and derivative SKUs is a really good question. Anybody else? I think we're all ready to go, looks like.
Thanks for coming.
Thanks, everybody.